Okay, what we're going to do this today is these four things. I'm of course doing some general info about this course. Hi, welcome. I'll explain the architecture of Ethereum, how it works from a technical point of view. And then we're going to play, which actually we're going to work with Solidity, and doing that via an editor which is called the Play editor. So then you can get started with Solidity. And then I'll give you some assignments, so that basically means that the rest of the day you will be practicing with Solidity and see how it goes, and then later on tell a little bit how it goes. This is where we started. This is where Peter helped to define all the educational goals of what you're going to learn, and all the subjects that we are going to do. Good morning. So this basically, you can check this, and it's basically it's just learning how to create a DApp and to program in Solidity. Well, defining this course, I made a couple of decisions. First, I wanted to do programming for a lot of blockchains, but then I realized, well, it's just too much to do it for a lot of blockchains. Even if you select one blockchain, like the Ethereum blockchain, there's so much to know and learn about it. That you can easily fill this entire course with it, and then you only barely touch the surface. So that's why I made a couple of choices to focus what we're doing. So I focused on one chain. I focused on a second generation chain. I'll explain a little bit later on the main differences between the generations of chains. And most chains are currently at the second generations, and the third generations are coming, but they're not really here yet. So they will be there later. Now, of course, Ethereum, that's the most used blockchain at this moment, and most developers are there. And I thought that's the main reason, and if you know Ethereum, then it's also relatively easy to learn other blockchains. So this is good basis. Then for the programming languages, it's of course Solidity, which is related to Ethereum. It's the main programming language of Ethereum. And accompanied to that, I'm using JavaScript. Because you also have to connect your Solidity to the rest of the world, to websites and to other kinds of things. And you can use lots of different programming languages for that, but JavaScript is also the mainly used one, so that's what we're focusing on. Well, good morning. Well, next to the blockchain, I'm also explaining a storage system, because on the blockchain you cannot store that much data, but there are other systems that work quite well together with blockchains, and IPFS is one of the mainly used systems on that. So that's why I chose IPFS, but there are also lots of alternatives. As an operating system for your laptops, I'm focusing on Windows. Because that's the most difficult one. If you have a Macintosh or Ubuntu, it's usually easier to do that. What operating systems do you have on your laptops? macOS? Windows? Any Ubuntu? Okay. So it's Windows and macOS. Okay. Yeah, no problem. So the most, actually all software works on both. So sometimes the installing is a little bit different, but it should be able to work on both. For the wallet, which is used to interact with your, with the blockchain, you can also use Solidity. So you can use Solidity to programs from a website. I'm using MetaMask, also because that's the most used wallet. In the meantime, there are dozens, at least a dozen different wallets, and they all have slightly different interfaces. But MetaMask is recognized as the leading one. So if you know that one, you can easily learn others. And if we're doing things on the mobile, I'm using the Opera browser because that's the browser that has the most features, and it works both on Android and iOS. Yeah, it's just the most features. So these are the choices. Well, how are we, or you actually going to learn? I will be explaining a theory, usually at the beginning of the class. And there's a lot of online material which I've collected on this website, which is actually a GitHub. And there's a lot of information below it, also lots of examples and links to other sites. So yeah, this is something you can have a look at and take pieces out. And for each subject there are lots of links, so you can choose. Also, I want to know about that subject, for example, about security or about vulnerabilities or whatever. And if you want to go really in depth, there are lots of links in there, so you can go as far and deep as you want. So I also want to stimulate that you do your own research and learn for yourself. Not that I describe every little piece, but that you also start learning things yourself. Actually, about blockchains, all the information is, there's a lot of information on the internet. You can find it on lots of places, but you do have to search for it. So yeah, it's good to start that habit and use all the resources that are on the internet available. Then there's quite a few tools that we're going to use. I've made a list over here. And during the lessons, step for step, I'll say, well, we need this tool now, we need this tool now. Well, you collect all of that, and then you learn, and then I will give the assignments each day. There will be a couple of assignments to do, and you just go do that, and you learn by doing that. And in the meantime, of course, it's good to ask questions to me, but also to your fellow students. And it's also fine if you work together on assignments, but I want that everybody separately puts the results of the assignments on the GitHub. Because yeah, if you just look at the shoulder, over the shoulder of somebody else, then you don't really learn that much. So I really want you to do on hands and create your own Solidity programs. So then you do your assignments, and then you put the result on the GitHub. So I've created a GitHub for every one of you. I've sent some invites for everybody. I don't know if everybody has already seen that and accepted it. Good morning. But the idea is that every teaching day, at the end of the day, you put something on the GitHub, and then gradually it will build to more and more. So this is what I will finally use also for the grade. I will look at the GitHub and see what you've put in there. So this will generally be the structure of like each of the days that we will use. Oh, by the way, the sheets, if you go to this link here, or just here and click again, from here you click to here, the sheets are also on there. So if you want, you can also open the sheets, and from the sheets you can click on the links to see other things. So the structure for like each teaching days, which will be like Monday and Wednesday, is that you prepare for that by doing, for example, a Crypto Zombies course or reading Mastering Ethereum. And in the day we'll do some theory, and of course I hope you have questions based on what you've prepared, and then you can ask those questions and we'll discuss about the questions. Then, I don't know, approximately 11, or it depends on how much theory there is, you will start practicing and continue later on the day. But usually we have in the morning in one classroom, and the afternoon is at a different classroom, so we have to change classrooms in between. And then later on in the evening I will ask you to present or tell about your experience of today, if you have been able to do the assignment, or if there are troubles doing the assignments, or if it's going well or not well. And then finally you put it in GitHub, and if you're very fast you can do that the same day, but if it somehow doesn't work out or whatever, you can also do that the day after, or late in the week, or in a week or whatever. Well, the grading will finally be, of course, based partly on the results of the part A, so that's the period before this. Also partly on the company assignments that you will also be doing, but this is my part which will help with the grading. So that will be mainly the source code in GitHub, which should be working code, so it should be able to compile and run. Otherwise, it's not mature. And connected to the GitHub, there's also a tool called Better Code Hub, which scans the software and gives some score about the software, how well it's putting parts, if there are test cases, if it's not duplicated, all this kind of things. It's also used in other courses at the Haagse Hogeschool, and the idea is that it helps to look at your code and to write structured code. But you can also, if you want, fool that tool so you can get a perfect score while your software is very bad. So it's not saying everything, but it's a nice thing to help you. Well, if your application looks nice, that also helps. And I would also like you all to participate in the lessons and in Slack, and also help each other. So the more active you are, the better that is for your grades. By the way, if there are any questions, don't hesitate to ask. No questions so far. Okay, these are all the subjects that I want to go through the entire period. And it's actually all building on each other. It starts with the basic building blocks, and the building blocks get a little bit bigger and bigger every time, and we get more complicated parts of building blocks that we've done before. And finally, here at the end, you will be able to create an entire working tab, distributed tab. Okay, now we go to next slides. Okay, now we're going into the real depth of the blockchains. Okay, here I've put a list of a couple of blockchains there are. In the meantime, there are lots and lots of different blockchains, tens, hundreds of blockchains, which mostly work differently technically. Some are copies of others, so they work sort of the same. Well, I'm focusing on the one in the middle, that's Ethereum. And you have the Ethereum, which is the public blockchain, which everybody can use without any problems, but you also have company versions of Ethereum. You have the Enterprise Ethereum Alliance, which is standardizing that, and Hyperledger Besu. That's actually one of the Ethereum implementations. They've renamed it to Besu. So this is what can be used in companies. Traditionally, they said, well, Ethereum can never be used in companies because it's open. But there are now ways to do that also. And the advantage to do that is that you can use the same tools, the same knowledge, the same everything that you have from the open system, and you can use that in companies. And there are currently lots and lots of tools at least every week. When I look at all the newsletters I get, there are at least a few new tools where I say, oh, that's a quite interesting tool. I wish I would have known about it before. So it's moving very rapidly at this moment. Okay, the principle of a blockchain. Of course, in the first part, of course, you already learned the basic things, but now I'm going to make it more really tangible, that you really can touch it and see how it feels. On the Ethereum blockchain, you have basically like 3 things that you can put on that. You can put on a transfer of ETH, so coins, Ether coins. You can create a contract, and you can call a function of a contract. So these are the 3 main things that you can put on the blockchain. And yeah, they're put first in, of course, in a mempool, and then the miner collects them and puts them in a block. And the miner gets some reward to do that. Does anybody happen to know what the reward is for Ethereum? For a block?
Yes.
The transaction fees.
Yeah, but you also get a reward for each block. I actually didn't know it myself, so I had to look it up. For a Bitcoin, it's a very large mining fee.
4 Ether or something?
It used to be 4 Ether, but now it's, I think, 2 Ether.
Oh.
So I think they started at 5 Ether, and every now and then they're lowering that a little bit, and it's currently 2 Ether. And I think also the gas cost, that also goes to the mining. But there is a block like every 20 seconds, and 2 Ether, that's I think 400 euros or something. And then I'm not quite sure, but still quite a lot. I showed this demo before at the Aula. If everybody has seen it. But I like this as a demo very much because it really shows what's going on, and it's also the real Ethereum, so the block numbers are real. You can also click on those things, and then you go to Etherscan and you can look into the block. So you can really see real time what's going on. And you see the different sizes of the blocks. And you see how many contracts are made. That's relatively few because it's the blue ones. You see them every now and then. Welcome. So here you see the new transactions that people want to put on the blockchain. They're put on, and this is the mempool, and then they're collected like every 20 seconds into the new block, and that's added to the chain. If you have any questions, don't hesitate to ask. Yeah, here's a small summary of the generations of blockchain. First, second, and third. The second, that's where we are now, and most chains are at this level. And the third are, for example, Polkadot and Ethereum 2.0, which are working on pretty hard now, but that's not nearly finished yet. So this will take maybe 1 or 2 years before that's finished. Polkadot is already running at this moment. I think it's still on testnet, but they are moving to production pretty soon. So that's one dimension, and the other dimension you have the public and the private variants, but I presume you already know about those differences. Now looking for more from a technical point of view, what's the difference, the main difference between those generations? Well, the first generation, that's like Bitcoin. Actually, if you see the blockchain as a black box and the users of the blockchain as the accounts, then the main function you would have as a user on Bitcoin is just to transfer currency to other accounts. So that's relatively straightforward, but still you can do a lot with it. And the blockchain is of course public, so everybody can read the state and see what's going on. And if you then open up the black box and look a little bit inside, you see the accounts here still here, and the account does an action like transferring Bitcoin. And at the top, first they are collected and ordered in the mempool. Then the miner is collecting them and putting them on the blockchain itself. And in the meantime, it's being replicated to all the blockchain nodes. So this is the simple start. Yeah, I had another picture in between. So here are all the transactions that are being collected here, and they are stored in sort of like a database which shows the state of the chain. So this is like the UTXOs in Bitcoin. Now, if you then go to the second generation, it basically looks the same, of course. You still can transfer currency, but you have mainly two new functions. One is to create a contract, and one is to call a function of the contract. So these are also the three colors we had before. And this, of course, gets a little bit more complicated. You still have the main parts here where you first ordered the transactions. And here you process the transactions. You also have a state, which is the state of the blockchain, and it's slightly more complicated, of course. And you have the smart contracts here, which you can create and call, and the smart contracts also can update the state. So this gets a little bit more complicated. Now, if you go to the third generation, there are more things to the third generation than just this. But one of the main things which you can do there is that you have an extra function here, that you can not only create smart contracts, but that you can also change the code of the blockchain itself. Not only program smart contract, but of course you can also program this. So you can mold your own blockchain with dedicated instructions for what you would really like. But we're not going into this path, but it's nice to know that it's possible. Yeah.
But then it's not so immutable anymore, is it?
Yeah, it's still immutable. Well, yeah, a blockchain is also, in one way it's immutable, but in another way it isn't, because it's immutable for everything that's in the past. You cannot change things in the past, but you can change things in the future. So with a smart contract you can update the data of a smart contract, not the smart contract itself, but the data it has in it, or the values of the balances of all the users, so that in the future you can update that. But yeah, if you would, yeah, I understand what you mean. If you would really want, then you could change the code so that you can also change the old parts of it. You could do that in theory, but there are some restrictions on that, that you cannot do that.
Okay.
So I've thought about that.
Yeah.
But if you were not careful, that would indeed be a problem. Yeah, that's true. Any other questions? No. Okay, now we're going to focus on Ethereum again. And in Ethereum you have basically two types of accounts. You have the externally owned account, so that's the one that the user has. And you have the contract account, and that's the one where the smart contracts are located. So this is what you have in your wallet. Here you have the private key, which you can use to do anything with it, to call functions and to transfer your ETH. And the other one is the contract, the smart contract. With the smart contract, there is no private key. There's only the public key, which is the address, but there's no private key. So nobody can use the private key to do anything with the smart contract. If you would have the private key of a smart contract, then you could transfer the ETH out of it. But in practice, you don't have those. Does anybody know how the accounts are created? How that works technically? Actually, they're just randomly created. You just randomly create a private key for this one, and there's a function how you can transfer a private key into an account and into the public key. So it's quite easy if you work in JavaScript. You just call a random function to create a random generator, and then you can just create your private key and create a public key out of that. And that's all there is to creating a contract, an account. So you can also make what's called vanity addresses. All those addresses are of course a hex number, but if you can just easily generate such an address, you can just try it out and do it in a loop and see if the numbers here start with any numbers that you want. So you have like contracts that start with 112233 or whatever, any hexadecimal number. And I've also tried it as a small program of maybe 5 lines to do that. And you can just keep generating those accounts. Yeah, but if you have the public key, so the address, you cannot ever reverse engineer it into the private key again. So that's the basic principle of the cryptography. These addresses are created a bit differently. They are based on this address, so the address of the accounts that created these smart contracts, combined with a number, so the number of transactions that's being done. So every next transaction will generate a new contract address. So, and here the addresses are directly created, so the public key and address are created here, but the private key just isn't there. It's not created, it's nowhere. So you cannot reverse engineer it because the cryptography is too difficult. And if you would maybe have a computer and keep it running for 1,000,000 years or longer, maybe then you would be able to do that. But it's probably even longer than that. In practice, nobody has the private key. Okay. Yeah, what all actions all have to start at an account like this. This is the only one that can do transactions. And these things cannot do anything by themselves. They can only be called. So whatever you do, you always have to start here. And from here you can, of course, create a contract like that, do a function call to a contract, and then it can do something. And we can transfer some E to it. And but then when this one is activated, it can do more or less the same as this one. So it can create another contract, or it can call another contract, or it can transfer it to another contract. And of course it's recursively, so this contract can do that the same. And from a contract, of course, you can send it to another contract, or you can send it to one of those, a user contract, an externally owned account. Of course, you cannot do a function call to this because there's no code behind this. So you can only transfer it to this. And of course, here you can transfer it. So actually, this is all there is to the smart contracts from a black box view. Now if you then zoom in a little bit further, then you have the three calls that you can do to a contract. And then here I have the contract itself, which will be in Solidity. So these are the things that you will be creating. And mainly there are functions in here, but there are two special kinds of functions. One is the constructor, and it's also called constructor. And that one is called when the contract is created. So when you create a contract, you can give also parameters to this function. And then in this contract, this constructor is called with those parameters, and you can do that to store initial values or names or whatever. The other special one is where there's a transfer of ETH, and where you don't have a function call, just you want to transfer some money to the contract. Then there's also a function being called in there, which is just named with two brackets. That has no other function name, and that's being called when there is ETH transferred to here. And it's also the other way around. If there's no function here, if this doesn't exist, then you cannot turn. Then you cannot transfer E to it. So you can only do that when this function exists. Now, when you do function call, then if you call function ABC here, then it's of course here called ABC. The function that you want to call here is called here. That's obvious. But because it's a permissionless system, Ethereum, anybody can try to call anything. So you can try to call a function which doesn't even exist in this contract. So then the question is, what would happen? And then what happens is it's also calling this special function here. It's also called the fallback function. So that's called when the function name that you want to call doesn't exist, then it's called over here. So you can do very interesting things with it, but it's the basic thing that you would need to know. this was all logical architecture basically. So that didn't really say much how it was implemented. Now I'm going to switch over to the physical implementation. So what software is there, and actually the things that you can sort of touch. So here I've put the blockchain, the Ethereum blockchain, and basically it's built out of nodes. Of course you sort of know that, but and nodes are just computers. And during the course we will also start or install these kinds of software on your PC, so you can see how that works. And these are the two main brands of software that are being used, the GET and the Parity. And within there, the smart contracts and all the data and everything is stored in here, and is all replicated between those nodes. Now here we have the PC with the browser on it, and the MetaMask. The MetaMask here has your keys in it, both the private and the public keys. And they can do a transaction to here. But then, of course, somehow you have to have a connection from here to here. So you could, in theory, have one of those nodes running on your PC, and then you can just interact it with it on your PC. That's theoretically the best way, but in practice that's difficult because it uses a lot of resources. So in practice what we see that we have gateways in here, in between. So they bridge between your PC and the nodes. As I told in the aula already, or asked as a question, why is this a problem? That's of course because this is a central point, like a central point of failure, but also somebody who's in between this and this. So that's not really with what you would like in a blockchain environment. But in practice, this most applications use Infura. Question?
Why doesn't Coinbase need it?
Because Coinbase has their own copies of the nodes. But there are other exchanges that probably will work this way. But everybody can run a node if you want. It's not that difficult, but you have to do it and install it and run it. But yeah, no, the advantage is that like a mobile phone can also easily use this gateway to here. So actually during this class, most of the time I will be using also Infura because it's really easy to do and it's easy to program. As long as you are aware that for a really important full-blown application that you wouldn't really want it. Okay. Yeah, and I put here an exchange in mainly because you need the ETH. If you don't have any Ether, you cannot do anything on the blockchain. So you cannot do a transaction or call function or whatever. You cannot just do anything. And it's how they finally made money. Of course, you have to buy the Ether from something like Coinbase. By the way, does anybody know where Coinbase get their Ether from?
From the sellers.
No. Yeah. Actually, it's from the miners. Well, they don't really get it. They buy it from the miners. The miners, of course, by mining they get the Ethers. They earn the Ethers. But they have to do something with it because, if they just keep it, they don't earn anything. So in practice, miners sell it to exchanges, and exchanges sell it to users, and then the cycle starts running. Okay, some other parts. if you want to create an application, then you also, in general, need like a website or other intelligence. And traditionally, you would do that on the traditional infrastructure, like the Web 2 infrastructure, like AWS or other kind of structures. So that is a combination which is used quite often. To combine this with this, but in the decentralized world, you also have a new option, and one of new options, and one of them is distributed storage, IPFS, and where you can also not only store large documents, but you can also install entire websites on here, which can function as complete websites. Then you no longer depend on this anymore. So this will also be a part of the course, that you're going to use IPFS and yeah, learn how to use it and to program it, which is not that difficult. And last but not least, here I've put the oracles. What are oracles for?
Storing data?
No.
Consensus?
No.
Verifying.
No. Oracles are actually the bridge between the outside world and the blockchain. So it's also the name Oracle is also based from the traditional Greek oracle, which tells the future or whatever. So it's the oracle on one side here connects to maybe websites or maybe a temperature collector or whatever, or the value of the dollar or all those kinds of things, and then puts that on the blockchain, and then from there you can start using it. Because on the blockchain, everything, all the programs that you put on the blockchain are immutable and they have to be repeatable, because everybody continually checks all the transactions and everything that's on the blockchain. And if, for example, you want the temperature here, and every time here you're going to check the contract and you go and get the temperature at that moment, and of course every time you get a different temperature, so that doesn't work. So you need a way to easily put in values that can be reused and that are stored there forever. And that's what we're also going to learn, how to make oracles or use oracle products. Okay, so this, what I just thought was, well, actually the main theory, and now we're going to move towards practicing with it. And to be able to practice, we of course need some tools. And the tool that I'm going to use is this one. It's from the Play project. That's one project from the Ethereum Foundation, and they have well, actually two main tools. We're going to start with this one. It's the Solidity editor. But this one is also quite nice. This is a collection of example smart contracts which you can use to find smart contracts. So maybe you can also all try to open this already, and you can see how it works. Everybody has a laptop? You all on this site already? Okay, so this is yeah, a very small but easy to use tool to create a smart contract. So this is what I also use to if I want to quickly try something out or create a small smart contract, or even if I want to create a smart contract which will be used in other demos. I use this one, and it's basically two things. Over here you have an editor, and here the smart contract yeah, is sort of shown. So you see here it's a small contract with two functions in it, and those two functions correspond here with the yeah, also the two functions. And you can here, for example, click on this arrow here, and you call the get function, and then here you call this function. And the other one is where you can set something where you can input values in it. So this is yeah, basically a smart contract. But if you want to do that, first you need MetaMask. So here I've put MetaMask. And does everybody have MetaMask already on his PC? Not yet? I'll show a little bit about MetaMask. You can try to, if anybody who hasn't got it yet can try to download it in the meantime. You can go to this website here and then download it. And I've also created a small video here where you can see how to install it. It's not really that difficult, but you have to write down your 12 words sheet, yeah, which is quite important to do, because if you forget to do it first, you think, ah, never mind, it's not important, I'll do that later. But if you do it later, then you forget. And I've had a couple of situations where suddenly MetaMask didn't work anymore or whatever, or you switch over to another PC, or your PC crashes or whatever, and if you don't have those seed words, then you can never get your contract back again, your account back again. So that also means you can never get your ETH back again. So when you have MetaMask installed, you can click here on this icon, and you get this screen, and here you can select the network where you're working on. And of course we want to start with the test network. Yeah, of course you always want to start with the test network. But if you start on the main network, then you actually have to pay with real Ether, so that's real money to do something on it. So that's costly. So if you click on that here, then you see different test networks, and Robston is the easiest to start with. Okay, then you need some test Ether, of course. You can do it in the meantime for everybody who hasn't got test Ether yet. If you go to this screen here, and you click on deposit, then you go to this, and you can go to a test faucet. A faucet is somewhere where you can get test Ether. And then you go to this website, and then you can request some test Ether, which you will need to use. did it already, and I have slightly more than one ETH on my Robson account. So I can use this smart contract. So if you have a valid contract, then it compiles, and then you can create this. But if you are still building your contract, and it doesn't compile yet, then you see an error message. Actually, what it does, it continuously keeps compiling your contract, and it shows you the error messages on the right, so you know what's going on. So if you have a valid contract again, then it compiles, and you can, if you go here, you can see the output of the compiler, and there's lots of details. It even here has the assembly code. It compiles to assembly code. So I'm not really going to use that, but just know that it exists. So this is a lot of information about the contract. Part of this we will use later on, but at this moment you can ignore it, and you can just keep here. Okay, then before we can do it, we have to publish the contract. And when you publish the contract, then so that's creating the smart contract on the blockchain. And you get a pop-up from MetaMask where you have to acknowledge that you really want it. And there you have to actually pay a little bit of Ether, and that's called gas. So you have to pay this amount to be able to do that transaction. Over here you can now see that it's pending. So it's putting it on the blockchain. And now it's confirmed, so now it's on the blockchain. Now we can put some value in here. Oh wait, something's wrong. It's quite cumbersome. Ah, now it's working. Yeah, you see now it has here contract, and you here see my address, which was used to create it. And now I can set a value. Which you also have to confirm. You see that in MetaMask again as a contract interaction. So that's where now I'm writing something to the contract. So that's put on the blockchain. Okay, now it's confirmed. So if I do get now, what do you expect will happen? Yeah, it should show 70. Yeah. So basically this is the first smart contract. Yeah, Christine.
Yeah, I have an error.
Error.
Yeah, I can't get the photos.
Oh, interesting. Yeah, I'll come back later for show with you. Okay, well now the idea is that you start to practice with this. If you already did something with crypto zombies, anybody started already?
Yes.
Yeah, a few. That's you also have an interface which looks more or less like this, and actually it's still based on Ethereum 4.25, so that's a slightly older version of Solidity, and the latest version is version 5. So there are some small differences, but the main things are the same. Let's see, there are. This one was I was looking for. Yeah, this is the what I make for every day. This is all the preparations which are quite useful to do. It's best of course if you do that before, but if you don't have time before you can also do it later, but this really helps to learn everything. So basically the crypto zombies, that's what I realized myself when I started learning this, where you learn quite rapidly. Here are all the sheets, and these are the assignments. So these are the things that what I would like you to do sort of the rest of the day. You first install MetaMask and get some test ether. Use the Ethereum Play, and then check out several demos. Over here I've recorded a couple of small films. Which don't work. Which is weird. That's better. No. That one doesn't work. But this one does. And here you can just follow the movie, and you can make it a little bit bigger here, or a full screen. And over below here I show exactly what's going on, and you can also click on it and then it goes to the appropriate part of the movie. So you can see here how you can interact with the editor and do that yourself. And then afterwards you can try it for yourself, and I have two collections of examples which you can use. So these two. Over here are a couple that I've created myself or collected somewhere else, and here are a lot of examples somebody else has created, and each example shows a little bit a function of Ethereum. So it's best for this one to start at the top and to just try them out one by one and just play with them and see what happens. So that's your assignment for today. Basically try things out, and at the end of the day I would like you to create a small smart contract and put it in the GitHub. And that would be nice if that's something of a use case that could be used in real life So maybe something, a small thing for an insurance, or for gambling, or for something where you register. Maybe if you work somewhere and the hours that you make, that you register the hours that you made in a smart contract, or that you book tickets or something. So all those functions in basics, they can be programmed in a couple of lines of Solidity. So I would like you to choose something like that and create a smart contract out of that. And of course, if you have any difficulties with that, you can just ask. And over here in the background info, there are lots of information about how Solidity works. But I think the best is just to go ahead and start practicing, and then we'll see how it goes on from there. Okay. Okay. So now we continue. This morning I showed to a couple of you about the Ethereum network, but not everybody was here. The Ethereum network is another test network, and it's also using a different consensus mechanism called Avalanche, but that's not really why I'm showing you this. But the most special thing is that it's a lot faster. So you've probably been using now the Robston test chain, some of you, and it's kind of slow. You have to wait like 20 seconds every time. And if you use this network, then it's about 1 second every time. So that's a bit faster. And I've shown here how you can set it up. It's basically here in MetaMask using a different network connection. And then afterwards go to the faucet here and get some new test ether for it. So you can do that later on from the links that I've put in the lessons. There are links to this on how you can set this up. And also the little movie that works now. So here you can see exactly what you have to do to set it up. So you can do it for yourself. Okay, one interesting thing that one of the guys, you had an error with his faucet. So I would like to use it as an example what you can do when you have errors. Because I noticed when I was working with Ethereum, whatever I try out, I always get errors everywhere. And to help the community to improve those errors, usually I try to report them somewhere. And then they get, sometimes takes a while, but eventually they get fixed, and then that helps everybody. So for example here, if you use this faucet, you just press the button to request test ether, then you get this error. And if you fill in this field and you also do this first and then you do that, then it's no problem. But a lot of not only we run into this problem, but other people also run into this problem. So what I did is I checked out I don't know if you can see it, but this is a Telegram group, and that's about Ethereum, and I was looking into that here, and I noticed that somebody else had exactly the same error. So we are not the only one who has the error. So then I went to the GitHub from Ethereum, and just Google GitHub Ethereum, and then you end up at the GitHub. And then I wanted to log an issue over here. And normally with GitHub, you over here somewhere you have an entry to issue to log issues, but I didn't see that over here. And then I noticed, well, this is forked from another repository. So it's a copy from a source for somewhere else. So then I went to the other repository, this one, and that also has a faucet. That's obvious because it was forked from there. And if you do that, it looks exactly the same. And when you press this button, you also get the error. So that's quite obvious. But luckily, there is an issues field over here. So here you can enter an issue. So that's what I did here. I just here opened an issue. Just telling what I did and put a picture of the error. And this is done usually the best way to get an issue solved, and then somebody who's responsible for this will see that in their mail that there's an issue, and then they say, oh, that's very easy to fix, and 2 lines and I fixed the error, and yeah, then it's fixed. And once it's fixed here, then Ethereum can copy that again and they can fix it too. And then I put it here on the Telegram Slack, the Telegram. Over here I said I got an error and I put it on the GitHub. And then I got a thank you from Emin Gün Sirer. Probably you don't know who that is, but he is one of the professors who is building the Avalanche ecosystem. And he's one of the more important guys around the world on blockchains. He's one of the guys who's been working on that the longest. So, well, then it's nice. He said thank you to me. So that also helps to get myself known in the wider community. So it helps several ways. So the message that I want to bring, that if you encounter error messages like this, then it's very useful to report them. This is how you do that. Okay, now what you've been doing today. How did it go with everybody? Have you been able to create something?
Not yet. Yes.
Not yet?
I guess some test, but not complete yet.
Okay. Anybody got stuck? That you didn't know how to proceed? I had a couple of questions which was quite good, so that's what I really want. If you have a question and you don't understand it, just come to me and ask them. So that's quite good. For example, there are a couple of questions like, for example, one was, can you use floating points in smart contracts? Anybody tried or wanting to use floating points? Yeah, yeah. Was somebody else trying to, yeah?
Yeah, I was trying to use it to send Ether from A to B,
Mm-hmm.
and I needed to record the amount of that.
Mm-hmm.
It was a bit difficult, but they say you just need to do an integer and use a formula to make it a floating integer.
Yeah, yeah. Yeah, because Solidity doesn't support floating points in the contracts, and that's mainly because different processes and architectures use different ways to store floating points, and that's very difficult for a blockchain. Then you cannot verify the contract and the data of the contract. So they just said, well, we don't support floating points, and you just have to use integers to simulate floating points. So that is possible, but it takes a little bit of more programming. So that's possible. Okay. Next time I want to explain a little bit more about Solidity, and then especially focus on things that are different in Solidity than in other programming languages. Because what I've seen from most of you, that you are quite capable of creating programs. Is there anybody who has problems with the basics of Solidity, just the programming itself, or just getting used to the difference between Solidity and other languages?
Just getting used to the difference.
Yeah, yeah, yeah. That's
very different.
Yeah, that's what I also guessed and anticipated. So I'll try to focus then next time, especially on the differences and the peculiarities of Solidity. I will do that during the course. There are straightforward peculiarities, but there are also things that are very weird, but they're also quite difficult to understand. So it's more useful to do that later on when you're sort of used to how everything works. Is somebody who thinks his example is good enough to already show it to the screen? No, nobody dares. Okay, next time I will have a look at a couple of them, and then also show them, just to show how it works and what you can do with it. Okay. Oh, let's turn it off. Yeah, almost. Well, it'll be okay. Has everybody got the GitHub account acknowledgement? Maybe it's a good idea now to the rest of the afternoon to try at least that you can put something on GitHub, so that you know you can upload the file, and then you can do it, your contract, if you're ready, either today or tomorrow or whatever. But then at least we're sure that you can access the GitHub. Let's see what else. Oh yeah, a general question. How did you like the fact that there was first a bit of theory and then you were able to practice with the programming? Did you like that, or would you like more theory?
Fine.
Yeah? It's fine?
A little more theory maybe.
Mm-hmm. Okay, a little bit more theory, but in general it was sort of okay.
Yeah.
Okay. Yeah, I hope that it would be a good way to practice and to be able to ask questions. And then I'll continue sort of along that path, and if you don't like it, just say it, no problem. Yeah, for the next day, that's Wednesday, we are going to focus on Remix. So Remix is a tool that's more or less like the Play editor, but it's more advanced. So you can do more things with it. It shows more information, but it's also, the first time you see it, it's a bit overwhelming. So it's quite useful to have the experience with the Play. That's good for simple things, and then continue with Remix. Yeah, it's also good to continue with the CryptoZoomWiz. If you haven't done the first one yet, and just try to do the first one, and if possible the second one. See how far you can get, and also continue reading the master and Ethereum, and see how far you can get, and then just also collect anything that you don't know about, or that you say, I don't understand it, or whatever. So that's if you don't understand it, maybe another one also doesn't understand it. So then we have good discussion about that. And then for Wednesday I will also have some more assignments, but basically that will mean continue programming your dApp and making it bigger and adding more features to it and add a website later on to it and adding oracles to it and
I
all
want
those
to keep on adding to what we started today.
yeah, you can keep on adding if you want.
I
But
mean,
if-
something really basic, so
Yeah, but you can elaborate on that, and if you don't like it, of course, you can also create a new one. You don't have to, but you can, if you want, continue to elaborate on that.
and if it's not finished, still push it to GitHub.
The idea is that when, only put something on GitHub when it's finished.
If it works.
If it works well, it's useful now just to put something on GitHub to see that GitHub works.
Yeah.
But it could be any text, the hello or whatever. But only when it works, then finally put it on GitHub.
Because I saw there was a folder for every day.
Yeah. That's the idea. That for each day there's a separate folder so that you put, for one for today. So expect one Solidity file there. Approximately like 15 lines or something. It doesn't have to be really big. But it should work. You should be able to put it in the play editor, and if you deploy it and push on the functions, something should happen. So it should compile and it should do something more or less useful. It doesn't have to be too useful, but it should work. That's the idea.